We are back with AP Calculus Lesson 1-4, Continuity at a Point. So, we've been talking about this word continuous. Thank you, Claire. Oh, I thought you were doing lights. That works too. What does it mean to be continuous, though? What is the actual definition? I'm still not going to give you a full-on definition until the second side of this. We'll get the actual definition of continuous. But for now, this is my favorite definition. I only discovered this like halfway through last year. My definition of being continuous, let's get rid of that, is this. A graph is continuous if you can trace the curve with a pencil without lifting the pencil. Without lifting the pencil. That means from all the way to the left side, all the way out to negative infinity, all the way to positive infinity. I can go from negative infinity to positive infinity with my pencil without ever lifting it. That means you are continuous. It's not just what's on the graph, it's from negative infinity to positive infinity. All right, so I want you guys to tell me which of these are, for each of these graphs, are they continuous or not continuous? The way we say that is discontinuous. So this first graph in blue, is it continuous or discontinuous? Quiet raised hand, Gia. It is continuous, write it down. I'm just gonna abbreviate C-O-N-T. It is continuous. Stego. Next one, orange graph. Is it continuous or discontinuous? It is discontinuous because I trace it, and then I have to pick up my pencil and then come over here. So it is discontinuous. Discont, and I'll abbreviate it like that. All right, Claire. Next one is continuous. And first one to it, discontinuous. Discontinuous because I have to pick it up. I can't follow this dashed line. That's just the asymptote. I have to pick it up and then come back up here. So, any questions up to this point? We know what continuous means. You can trace it with a pencil. Don't pick it up. There are 4 general types of discontinuities, and depending on who you ask, they might classify these in different ways. Like Wikipedia only has 3. A bunch of other online sites have 4 or 3. These are the 4 that you need to know for AP Calculus. If you use these words, they will know roughly what you're talking about. They're still not official because everyone still defines it in their own way. This is what I call a hole. Write it down. This is a hole. It is the first type of discontinuity because obviously I have to pick up my pencil so I don't accidentally go through this point. A hole could also look like this where you have a point up here. You still have to pick up your pencil, dot that, and then come back to this function. So that is still a hole. You can have a point up there, still a hole. All right, this next type is called a gap. Because all of a sudden, I have to jump all the way down here. It's called a gap, pretty straightforward. This one, I couldn't really come up with a good name for it, so I'm going to call it an end. This one ends. I come from the right, and all of a sudden, I can't get out to negative infinity because it ended. So if I can go from negative infinity to positive infinity, it's continuous, but I stopped. All right, and then lastly, we have VAs. Vertical asymptotes. Vertical asymptotes will make it so that you can't draw it with a continuous line. And notice that you can have one that goes to negative infinity and to positive infinity. Maybe they both go to positive infinity. Maybe they both go to negative infinity. Either way, a vertical asymptote is a discontinuity. There are 4 types. That is one of the things you need to memorize now. When I say, what are the different types of discontinuities? You'll immediately yell. VA. And VA stands for? Perfect. Okay. Just make sure we know all of it. It's just another thing that we have to have memorized. All right. So this is the formal definition on the back of what it means to be continuous. If you are continuous, then I need someone to read this whole line for me. Who can read these? Claire, go for it.
The limit of f of x as x approaches c from the left is equal to the limit of f of x as x approaches c from the right, and that's equal to
F of c, and how do you pronounce F of c?
the height
Height at
of
x equals c. Perfect. Yes, so, and that seems really complex. I mean, when you go to college, they're not going to have any explanation aside of, yeah, that makes sense to you, doesn't it? It's confusing even to me still. Well, maybe not as confusing because I've seen this many, many times, but it's just saying these are all heights. Each 3 of these is a height. They're saying all of these heights come together at the same height at the same point. So, the left height is equal to the right height is equal to the actual height. All of these have to deal with heights. So the left height is equal to the right height, which is equal to the actual height at this x-coordinate called C. We're approaching the limit as I go to C, limit as I go to C, the actual height at C. And C could be any point. It depends on the graph. Like for the graph up here, maybe my C was -2. Well, as I get closer and closer to the left, I go to D and E, a positive infinity. As I get closer and closer from the right, I go to D and E. What is the actual height? There is no actual height. It's also D and E. As I come from the left over here, it doesn't exist. There is no limit as I come from the left because there is no left. So that's a D and E from the limit to the left. Limit from the right obviously goes to a height of 0. The actual height at 0 is 0, but 0 equals D and E. All three of these have to be the same, and they can't all be D and E. They have to be the same number. So, in summary, these are all heights. They have to be the same number for the height. All right. So, 2 examples where we're using this continuity test. And this is going to be one of those things where I probably won't review the continuity test for a while until the pre-test, and then after Unit 1, you won't see it again until maybe the next test, so you'll have to just try to remember this. A lot of these other ideas, like what the different types of discontinuities, those get lots of review. This one doesn't get as much review, so like when it pops up for the final, you'll be like, oh shoot, I'm trying to prove things with limits. That's the continuity test. What did that say? And you'll have to remember this definition. When you actually write down your proof, you have to write down this thing. The limit as x approaches this thing from the left equals the limit as x approaches that other point from the right is equal to the actual height of that point. You'll have to memorize this symbolic definition. All right, so I need to prove, keyword prove, that this function h of x is continuous. Using the continuity test. If you ever see prove, that means you're using the continuity test. Let's set it up. Let's rewrite it. Everyone rewrite this right now. The limit as x approaches, and it's not C now. C is what I call the suspect point. So this C right here, I'm going to call that the suspect point. Please label it in your notes. Suspect point. We don't know if that point is continuous or not. He's a suspect. We don't know if he's guilty or innocent. So this 2 right here, that is also our suspect point. Label it. This 2 right here and this 2 right here, those are our suspect points. It's the same point. This number will always be the same. The same from the left of that point and the right of that point, these functions happen. And what happens at that point, because we have an equal sign here as well. What is happening at that suspect point? We don't know, so let's prove it using the continuity test. So we have the left piece, the right piece. We know that the first one is left, the second one is right. All right, now we're writing out this definition. I'll write it slowly with you. You can probably go faster than me. The limit of this function is not f of x now, it's h of x. The limit of h of x as x approaches the suspect point. Well, the suspect point isn't C, it's 2 now. As x approaches 2 from the left, that now needs to be equal to the rest of it. Limit of h of x, this function, as x approaches the suspect point 2 from the right, needs to be equal to the actual height of h of x, so h of 2. We're rewriting that definition of the continuity test, and now we're actually going to find what those are. What is the limit as x approaches 2 from the negative side? So this is a review from yesterday. I'm going to give you time to think. What was it? Claire knows. But what was it? How do I find that? Do I plug into the left? Do I plug into the right? Do I plug into that first equation, the second equation? Which one do I plug 2 into? Claire, tell us.
So you plug in the 2 into x plus 2 because that's approaching it from the left and you get 4.
All right, yeah. So plugging in 2 to the left because that is the left from the left. 2 is x now, so it's 2 plus 2. 2 plus 2, Claire told us, was 4. So this height is 4. All right, it's going to be either stego or geo. There are 3 parts of this. So that means everyone gets to participate once. What is the limit of h of x as x approaches 2 from the right, from the positive side, between stego and geo? What is it and how did you get it? 4. How'd you get it, stego? Oh yeah, you plugged it into this equation because that's on the right. 2 squared is indeed 4. Ask questions now if you're confused or if you want some time to think about it. We're all good. All right, Gio, you're up. What is h of 2? What is the height at 2? How'd you get that? It is correct. A good guess. You are correct. But how do you get that? Someone else help him out. You plug in 2 to which one? The top or the bottom of h?
Top.
Top. Why the top, Gio? It has to do with these symbols right here.
Because it's equal to.
Exactly. You're looking for equal to. At that point, at this height, at the actual height, I have 4. All right. So, are all 3 of these the same?
Yes.
Therefore, we can say what?
It's continuous.
Exactly. So we say, therefore, continuous. Then you can say, because passes continuity test. If any one of these 3 are different, that is a fail. You have failed the continuity test. All 3 of them have to be the same in order to pass the continuity test. We're going to be doing a harder version of this. And this version is the one that you will almost always see on every single AP exam. That means this is a point. If you know how to do this, this is 1 point of your AP score. Because each multiple choice question is about 1 point, depending on what you're scaling it as. So if you know how to do this, it's an immediate point right now. How do I do this? It's continuity test because I'm talking about being continuous. I have a piecewise function. Claire, what am I doing?
So because the top equation is completely filled out, you can figure out what the limit is. The limit is going to be for that one, and then you can set it equal to the bottom and figure out what case it's going to be when you plug in 1 for x.
100% correct, exactly. And backing up to make sure that everyone is following me. Use the continuity test. If you need to write them out, write them out. Because these are probably going to be multiple choice questions, by the way. The first 5 units in this class are all multiple choice, which means you don't have to show your work, but you should. But for the AP exam, you definitely don't have to. For my class, I want you to show your work. So for this one, I'm going to show my work. I'm going to use the continuity test. The limit of g of x as x approaches the suspect point. What's the suspect point here? 1. And I'm going to go from the left, so I'm going to put a minus sign. That needs to be equal to what?
So equal to the limit of g of x as x approaches 1 from the right.
Exactly, as x approaches 1 from the right, which is equal to stego. G of 1, yep. There it is. We're going to find all 3 of these, although you don't really need to find all 3 of them because this g of 1 and the limit of g of x as x approaches 1 from the left, these 2 are the same. I'm going to box these. These 2 are the same equation. I'm not going to have to do double work. They're the same equation, so kind of ignore this one. It's the same as left limit. So don't worry about it. Since it's the same, I'm only going to have to set these 2 equal to each other, which is what Claire was saying. Set these 2 equal to each other and figure out what they are. All right, I'm plugging in the suspect point. I'm plugging in 1. Where? Top equation. Gio, do it for us. What's 1 squared? 1 times 4. Okay, so that's the first number. And then plug in 1 again. 3 times 1. So minus 3 plus 1. And what does that add up to? 2. So you have found that the limit of g of x as x approaches the suspect point, 1, from the left is 2. That now needs to be equal to when I plug in to the second equation. I'm plugging in the suspect point. Always plug in the suspect point. All right, who can do that for me? Go for it, Claire.
2 is equal to k
Plus
plus 5.
5.
Because 7 times 1 is 7 minus 2 is 5.
Exactly. We plugged into this second equation. It's so important that I think I'm going to write it out here in red. Plug in the suspect point. That's all you're doing over and over again. All you're doing is plugging in the suspect point. You just have to figure out where to plug it in. So Claire plugged in 1 to the second equation and got k plus 5. Well, that's what it's saying. I want this to be continuous. The question is saying, for what values of k is this function continuous? Well, now I just have to solve for k and I'm done. So k is equal to, yep, -3. Done, box it. It's always the continuity test. Every time you're asking, is it continuous? For what values is it continuous? Think of continuity test. So you have 2 things to remember today. 1, the continuity test. The left limit height, right limit height is equal to the actual height. And then how to use that, plugging in the suspect point. That's the first thing. The second thing, what are the 4 types of discontinuities? So know their names, know what they look like in your head. All right, don't write your summary. You're going to Cornell your notes when you get home. For now, we're going to work on homework. Any questions before we work on homework? All right.